Hello, my name is Bruce Whitfield. This is ECEN424 Section 1. This is Project 1. This is the VHDL for the LCD display, which is the PMODCLP connected to my base 3, which is part of my traffic light project. I set up the entity with a button reset, clock, current state, which is 3 bits, which is a 3-bit input, which will determine what the LCD display will display based off of the output from the finite state machine. I have JB and JC, which are the output buses from the base 3, which will take the input pins from the PMOD. I got this outline of code, like the structure at least, from the LCD tutorial that was displayed on Blackboard and as well on Digilent. So this is a type M-state that was created. And then this right here is signal and declarations, and then I created a type LCD CMDS_T, which is an array that's got a range from 15 down to 0 of standard logic vector from 9 down to 0. Now the when the reset button is hit, then it will display reset, and then in the first state it will display A south green turn green, which stands for A street green turn arrow green. And the next state is A south green turn yellow. Next state is A south A north green. The next state is A south A north yellow. The next state is B east B west green, and the next state is B east B west yellow. Then the next state is C street green. The next state is C street yellow. And then I have a pointer set up to go through the array. I have a process block, which has current state in the sensitivity list, and current state is a selector for the case statement. When the input is 0, 0, which is the current state input, from 0, 0, 0 down to 1, 1, 1 is from all 8 of my states. And whenever it is in state, when input 0, 0, then it will be A south green turn green, A south green turn yellow, and so on and so forth on what I explained up top. I just have it connected there so it knows based off the input what to display. Now this rest is code that was part of the tutorial, and the only thing that I changed is this process right here with clock and the sensitivity list. If clock is 1 o'clock if it happens, and if the clock count reaches 1, 1, 0, 0, 1, 0, which is 50, then the clock will reset and it will perform a not function on the US clock. If else, it will add 1 to count. And then this is the process block for the delay. And then the next part determines when count has gotten to the right number depending on the state. And then the rest is just code that kind of just came off of, it's just like the basic structure. The only thing I really did add at the bottom is for the JC and JB bus output buses. I just added that part because I'm specifically using those buses. And I use this as well to port map the input pins from the PMOD to the output buses on the base 3. And as you see, with an end result after synthesizing, after running the implementation, generating bit stream, and also programming the device, I get a LCD display of A south green turn green, which is the first state in my finite state machine. And currently at the moment I don't have a top level program connecting all my components together, so at the current time this is the only thing it will display until I have the finite state machine connected to it, feeding it in that current state input. And this will complete the demonstration for the LCD display. Thank you.